Alright, so in solving your Brayton cycle, you have another relations over here that you can play around in order to obtain one of the value needed. It's either temperature, pressure, or your specific volume over here. So in order to use this relation, the working fluid must be an ideal gas, and it is valid only for isentropic process and at constant specific heats. So the isentropic process in your diagram over here is happening at process 1 to 2 and process 3 to 4. So I will show you on how to make use of these relations. So the first questions asked is for you to find your T3, and in the question it's already given for your state 1 and your state 2. So when you want to find for your state 3, it's either you can make use of this isentropic relation, which is in between 3 and 4, by using this equation, or since it already given you the value of your heat additions, which happenings in between state 2 to 3. So you know that heat addition is actually the process in between temperature at 3 minus your temperature at 2. So in this heat addition, Cp is already given, Qin is already given to you, and also T2 is already given. So when you rearrange your T3, you will have Qin over Cp plus your T2, and finally this will give you 1575 Kelvin. So from this T3 that you obtain, you will be able to solve for your state 4 over here. However, the questions wants the actual value, which is your T4A, not the T4. Therefore, you will make use of this isentropic efficiency relations. So you have the isentropic relations of your turbine. It's actually your actual work over your isentropic work. So in this case, your turbine is in between state 3 and your A, and then it is equal to 85% or 0.85. But because you are dealing with your ideal gas, so your H3 now is actually your CpT3 minus your T4A over your Cp T3 minus your T4S, which is equal to 0.85, where your Cp here can be cancelled out, and that your T4S can be obtained from these relations. So you have T4S over your T3, which is equal to P4S over your P3. In this case, this is gamma minus 1 over gamma. So when you want to make use of this relation, make sure that you're using the given value you are using the given value. So in this case, we already know the pressure in this both constant pressure line, and make sure you always put the unknown value to the left and to the top of your equation in here. So let's try to solve this. Finally, your T4S is equal to T3 P4S over your P3 is 0.4 over 1.4, and it is equal to 885.7 Kelvin. So now you get your T4S, which is this one. You can plug into your equation here, and the T3 that you obtained previously to be set into here, and when you solve, you will get your T4A value, which is your T4A finally is equal to 989.1 Kelvin. Alright.